Okay, ladies and gentlemen, the next reaction types we're going to go through are single displacement and double displacement. So we've already gone through combustion reactions, synthesis reactions, decomposition, and our last two are single displacement and double displacements. Now they sound very intimidating, but they're not. They're not very really that difficult of reactions either. Definitely something you guys can manage. Okay, so just to recap the other three types of reactions, a combustion reaction. It's going to be something like taking, CH4 or methane plus oxygen, and if it's good, nice clean combustion, CO2 and H2O. Synthesis reaction would be something like taking sodium and chlorine and making sodium chloride, and then decomposition would be the opposite. Okay, taking sodium chloride, breaking it down to sodium and chlorine. Okay, and again, making sure we have that 2 there because chlorine's a diatomic. Okay. We're now going to our third reaction type, and they're called single displacements. Okay. So single displacements reactions always involve the same 2 things. It's going to be an element and an ionic compound. It's always going to be. And then it's going to result in making an element and an ionic compound. So you're going to see an element and ionic compound on both sides of the reaction arrow, both the product and the reactants. So if the reaction happens, I'll put if there because we're going to talk about what if it doesn't, but if the reaction happens, the element or the reactant, whether it's a metal or a non-metal, will basically replace the metal or non-metal in the compound. Okay? So I'll kind of show you what I'm talking about there. So we take the element. Now this element over here can be a metal or a non-metal. Those are only 2 types of elements. Okay? And it's going to react with an ionic compound right over here. Okay? What ionic compound is, again, composed of a metal and a non-metal. So all that's going to happen is if A is a metal, so if A happens to be a metal and B is a metal, A and B are just going to switch. Okay? And then A is going to form with C, making an ionic compound over here. And then B, which was in the compound, now is a lone metal. Okay? And that's basically the idea. Now, some people like it with A's and B's. I prefer it with actual elements. So let's go a couple examples with actual elements. Okay? So if we take a look at the reaction here, right? So I'm going to highlight this reaction right here, right? So on the left side, we have an element, zinc, reacting with copper chloride. Right? Now, one handy really thing to do, and I strongly suggest you do this, okay, is basically kind of clarifying, well, what are they positive or negatives? So metals are always positives, so I'm going to put a positive over that. I'm going to put it just above it, actually, because that looks like it was a bad idea to write it right over top. Okay, so a positive over zinc. Copper is also a metal, so that's positive. Chlorine's a non-metal, that's going to be negative. Okay. I'm going to do the same thing at the bottom. Okay, bromine is a non-metal, so that's going to be negative. Okay, K is potassium, that's going to be a positive. And then iodine is a negative. Now, let's see what happens during this reaction. Well, if I have a positive by itself, the element, and here's my ionic compound, this positive is not going to be able to bond with another positive. You can't have zinc and copper bond together, okay? They don't bond together. They're 2 positives, they're going to repel each other. Metals don't bond with each other. They do something else. So the only thing that zinc can potentially bond with is chlorine. So what's going to happen is zinc is going to come in and basically kick out copper, and it's going to bond with chlorine. And then you're going to get zinc chloride, and then since you kick copper out, it's all by itself again. Okay? Now again, the most important thing is remembering you have to do the crisscross rule when you do this. So you should look up zinc is 2+, chlorine is 1-, and you do the crisscross rule. Okay? But whenever you form a compound over here, make sure you do your crisscross. Now, if we look down here, this is a little different. Okay? Here we've got a negative, bromine, and it's going to interact with the ionic compound potassium iodide. Well, bromine is not going to be able to bond with iodine. They're both negatives because they're both nonmetals. Okay? So what's going to happen is bromine is going to want to bond with potassium, and that's what it does. Potassium and bromine come together, and that's what we get over here. Using the crisscross rule, K is 1+, Br is 1-. You do the crisscross and you get KBr. And then that leaves iodine all by itself. So basically what happens is you look at the lone element, Okay, you're going to have a lone element and then a compound. You take a look at the lone element and say, is it a metal or a non-metal? If it's a metal, it's going to kick out the metal in the ionic compound. If it's a non-metal, it's going to kick out the non-metal in the ionic compound. So let's take a look at a couple examples here. Okay, I'm doing it by hand here. Okay. So in my example, I've got aluminum. So there's my element. Okay, it's going to react with my ionic compound, magnesium hydroxide. Now again, like I mentioned before, it's a good idea to put the positives and negatives. So aluminum's positive, magnesium's positive, and the OH is negative. So I know in this case, what's going to happen is the aluminum and the magnesium are going to switch because they're both positives. And if the aluminum magnesium switch, well then I know I'm going to get magnesium on its own. Okay? And then I'm going to have aluminum and hydroxide bond together. But I have to make sure I form it properly. So I have to say, okay, well, aluminum is 3 plus. Hydroxide is 1 minus. If I do the crisscross rule, I'm going to get Al1 OH3. Okay? And that is finishing out the reaction. Okay. Now let's go through another example. Okay. Now I have chlorine acting on my ionic compound magnesium oxide. So here's my element, the chlorine, and then my ionic compound magnesium oxide. And again, I always like to, it's a good idea to start with, well, this is going to be negative because it's chlorine. My magnesium is going to be positive, and then my oxygen is also negative. So what's going to happen here is the oxygen and the chlorine are going to switch because they're both negatives. So I'm going to get oxygen on its own. Right? And again, whenever oxygen is on its own, it's diatomic like chlorine is, so it's going to be O2 plus. Now magnesium was bonded to oxygen, but now it's going to bond to chlorine. So I'm going to get MgCl, and if I do my crisscross rule properly, I get MgCl2. Okay. So in this course, basically you have to be able to do a couple things. One, you have to recognize that this is a single displacement reaction. Okay? So you have to say, okay, when I look at this reaction, this is single displacement. How do I know that? I have an element plus an ionic compound. Element, ionic compound. Okay? That's your indicator that it's a single displacement. So that's the first part you have to be able to do. Now the second part is being able to predict, well, what is the product's going to be? Okay? And really all you have to know how to do there is use the crisscross rule. Okay? So if I'm going to do my prediction here, I would say calcium, that's positive, aluminum's positive, oxygen's negative. So if they are going to switch, that means that my calcium is going to switch with aluminum. So aluminum's going to go on its own, and then I'm going to get calcium bonded to oxygen, so that would be CaO, because they're each going to be 2 plus, 2 minus to do my crisscross rule. And calcium oxide. Okay. Now let's take a look over here. Br, O, that's negative. Mg, positive. O, that's negative. What's going to happen here, the two negatives are going to get switch, and I'm going to get O2 plus Mg, Br2. Okay. All right. Now, the next part is double displacement reactions. Now, this isn't much different than a single displacement reaction. Okay? But when you look at them, they're the easiest to identify. You're going to see basically 4 ionic compounds all the way across the reaction thing. You're going to see 2 ionic compounds on the left side and 2 on the right side, and that tells you it's a double displacement reaction. Okay? And all that's really going to happen here is the metals are going to switch. So you just basically switch the metals, and then you have to reform them using the crisscross rule. Okay, it's a double displacement. Instead of just one thing switching, now you're going to have 2 things switch. Let's take a look at some examples. Okay. So if we look down here, what we have is we've got KNO3. So what I have here is I've got, that's going to be my metal, and there's my metal. And then the NO3 is a polyatomic, is my nonmetal, and there's my nonmetal. So all that's really going to happen here is the two metals are going to switch. Potassium, which is K, is going to bond with chlorine, and then aluminum is going to bond with NO3. And that's all that happens. Now, the only challenge here is we have to make sure we use the crisscross rule when we reform them. So I'm going to take aluminum and I'm going to bond it with NO3. Well, when aluminum and NO3 bond together, 3 plus on aluminum, 1 minus on NO3, and I get AlNO3 to the 3. Okay, you're just using the crisscross rule. And then when K and Cl bond together, because I'm just combining K and Cl, I do the crisscross rule and I get KCl. Right, so let's take a look at some more examples here. So I've got NaCl plus MgO, okay? Two ionic compounds, ionic compound, ionic compound. I know it's a double displacement. And then again, I always like to write, I'll pick a better color here, positive over the sodium, negative over chlorine, positive over magnesium, negative over oxygen. Because oxygen's non-metals, so with chlorine, and magnesium and sodium are metals. Okay. So now all we have to do is basically we have to say, okay, well, magnesium and sodium are going to switch. Okay. So if sodium is going to bond with oxygen, then I have to do my crisscross. Sodium's 1 plus, oxygen's 2 minus. If I do the crisscross, that would make Na2O, because sodium bonded with oxygen, and I do the crisscross, plus, well, what if magnesium now bonds with chlorine? So I have to do the same thing. Magnesium, 2 plus, chlorine, 1 minus, crisscross, and I get MgCl2. Okay? It's not much different than a single displacement. The biggest thing is making sure that you actually use the crisscross rule every time when you reform them. You can't just write them out. Okay, let's do another one. So we've got CaNO3, positive, negative. Aluminum's going to be my positive. Oxygen's going to be my negative. Okay. So what's going to happen here is the aluminum and calciums are going to switch. So calcium is now going to bond with oxygen. So when calcium bonds with oxygen, I use my crisscross rule and I get CaO. And then when aluminum bonds with nitrogen, I'm going to get AlNO3. 2 to 3. Right? And that's just using the crisscross rule. Over here, sodium's positive, magnesium's positive, negative, negative. They're going to switch. Sodium bonds with oxygen, and magnesium bonds with bromine. Right? And again, making sure you use the crisscross rule every time. I'm not showing them all just because, well, just for time concern. Now, you'd have to go one step further in balance, but I don't really want you to worry about balancing right now. We'll worry about that afterwards. I want you more worrying about making sure we can predict the products. All right, so I'll be giving you some learning check tomorrow related to these two things, and hopefully that can help you out.